Okay, so today we're graphing logarithms. I just told them that a logarithm is a what, everybody? An inverse, they just said it, of exponential. So I went through this process of here's an exponential. When I say inverse, you say not outverse. Stop doing that. Switch x and y, and then resolve for y. Okay, that's just to prove where a logarithm comes from and that they're inverses of each other. Okay, so great. All right, and then you can look at the notes online to read that better. And then, is this a logarithm? Yes or no? No, you already said this fourth hour that this is an exponential graph. Stop screwing around over here. This is why we don't have A triple pluses. You must focus. Okay? Hey everybody, what's 2 to the 0 power? Input, say it. 0, comma 1. You plug in 1. Here we go. Look at it. This is like a fly. He's got the common. You have the attention span of a common housefly over here. Okay? You're just a. I'm just trying to do stuff up here, and you have papers flying all over the place. Good Lord. And by the way, Lord is just a person that is in charge of something, not in any particular religion or anything like that. So 2 to the first is 2. What's 2 to the negative first? 1/2. Shh. Okay? There we go again. Why does he keep asking these stupid questions? When I say inverse, you say, stop saying outverse. Switch x and y. Okay, so what's the inverse of y equals 2 to the x? Well, you'd have to switch x and y and turn it into x equals 2 to the y. You got me? Then change it to a logarithm. And then it turns into log base 2 of x. Or, okay, so you don't look at this picture yet. We'll actually give coordinates for this. And actually, the blue graph up above is the y equals 2 to the x graph. Okay? Now, when we switch x and y and resolve for y, this can be considered y equals log base 2 of x. Okay, what was the coordinate for the 2 to the x? 0, comma 1, right? When I say inverse, you say, do it again. Switch x and y. Doesn't that become 1, comma 0? That's the most important point you need to remember for a logarithm. I don't care what the base is until it's shifted, of course. You know exponentials get shifted. But I told you when we were graphing exponentials, what are you two doing back there? Oh my God, they're playing patty cakes or something. Okay? You see what I deal with now, internet, about teaching high schoolers. Okay? And then there they are. They are yeah, all right, great. And then 1, comma 2 becomes what, everybody? 2, comma 1. And then you know what? It's like for the exponential, what's 2 squared? 4. So that's 2, comma 4, which now becomes 4, comma 2. You get the point. This is still going to rise, but it's just going to rise slowly. There is no asymptote for this part of the graph, but there is here because remember that one graph, that point which was negative 1, comma a half, right? This is negative 1, comma a half, which is now half, comma negative 1. When I say inverse, you say. All right, and then notice this. What's that the sound for? Symmetry about the y equals x line. So the bottom graph is the graph of a logarithm. Okay? All right, here's one more thing I'm going to be abstract about. For this one, I love that. This is so boring. Whole bunch of stuff going on in fourth hour right now. Hey, wouldn't you agree on this point right here on the horizontal asymptote is 1, 0? Switch that one. What's 1, 0 become? You know where 0, 1 is? It's on the y-axis. Wouldn't you agree that this is negative 4, comma 1? Switch that one. Or 0, I'm sorry. Negative 4, 0. Made a mistake there. That's 0, negative 4, which means logarithms have what kind of asymptote? A vertical one, and that's always. So these are things that are going to have to be memorized. We are still going to approach graphing logarithms by input, say it, output, to make sense. So yes, we should know 1, comma 0. I want to know where that point moves to when we start transforming the graph. But I also need to know always a logarithm has a vertical asymptote, and it is an always. It is an always. So here's what you can write down. Here's the basic. Sorry. I did want to do this too. Not yet. Okay, write this down real quick. Okay, what about when the base for an exponential is between 0 and 1? Well, we know that 0, comma 1 is still a coordinate for an exponential. When I plug in 1, I get a half now. When I plug in 2, I get a fourth. And it approaches the asymptotes from this side. And it decreases when I look at that picture. Okay, right? And then when I plug in negative 1, I get 2, because 1 half to the negative first is 2. And we talked about the negative exponent rule way back then. Remember your book of functions? Input, output, that, and that's what we had for this. So the reason I wanted to talk about this, when the base is between 0 and 1, then when I switch x and y, then this is the logarithm graph I get. Still, 0, comma 1 becomes 1, comma 0. Again, the most important point that I need to know where it moves to for a logarithm. But then when I take 1, comma half, that becomes half, comma 1 when I switch x and y. When I take negative 2, comma 4, I'm sorry, I'm going the wrong way. When I take 2, comma a fourth, that's what this point is right here. Sorry, I looked at the wrong part of the graph. That becomes 1/4, comma 2. So there's where we're approaching the asymptote vertically on the logarithm when we switch x and y. So it's a really good way to look at logarithms. Look at its exponential inverse and invert those coordinates to see what the logarithm looks like. And then remember. I can't help you if you can't memorize these things. But you know it's always an escape? Input, say it. But then actually knowing how to evaluate. That is another problem I think we're running into here. All these little tricks that Mr. S is trying to give you to be good solvers of stuff. Okay, yes, we are moving. All right. So here's the synopsis of logarithms. You have one of two cases. And the book really doesn't cover when the base is between 0 and 1. But as a teacher, I must show you that, and then maybe on a worksheet later, we'll have graphs like this. More than likely, you'll have the red version on the left. You'll have bases that are greater than 1, log base 2, log base 10. They love log base e. What's log base e, everybody? Well, it's log base what? Or what's it called? Log base e is called what? ln. But the base is what? E is what? 2.718. So it would be very similar to what the log base 3 graph would look like, or the log base 2 graph would look like. And then I'll show you the properties that we have from our property book. But this is what you should know. When b is greater than 1, it is increasing like this. It crosses through 1, comma 0. I would like you to input a couple coordinates in order to get a little bit of shape. And I'm going to show you how to do that. Even when there's transformations, because then it'll verify your transformations correctly. And then when the base is smaller than 1, or between, a better way of saying it, between 0 and 1, some fraction less than 1, then the graph decreases based off of the reflecting of coordinates of the exponential graph that I just showed you. And then I'll zoom in. Remember these properties? If you wanted to write the pertinent ones, go ahead. This is from your book of functions, and I'll press pause. One important note is what's restricted, or what has a condition that's special, the domain or the range. Look at the picture. The domain is definitely restricted. You can't take the log of 0, and you can't take the log of negatives. It's not evaluatable, if that's a word. I don't know why that's up there. So that is why the domain for both of these red and blues is 0 to infinity, not even including 0, because you press log of 0 and you get undefined, or it doesn't work. 10 to what power equals 0? Not going to happen. Okay, anyway, you can look at all the rest, and it's pretty easy. All right, so we're still going to graph by input-output. Oh, I'm sorry. And of course, those are the parents. And the parents make babies. And and those babies always have little variations. That's called genetics, right? No, never mind. Um, so we're going to shift those. You know what? These are no different than any other function, correct? Okay, but if you want to write them in terms of logarithms, go ahead. There's a negative in front of the logarithm. That means there's an x-axis reflection. The graph of the parent function gets flipped. But you know what? We're still going to input-output to verify. Then maybe look back at the equation to make sure my graph at the end does fit the transformations. Oh, that is so smart. You were actually getting different notes than even students last year. Based off of, remember that one day where we graphed just every of those parent functions through transformations, but I still told you to input-output? Do you remember that? Well, it's going to happen again. I don't like when there's a dilation. It's okay. That's kind of complicated. I kind of avoid that for this first day. I want you to get the idea, just the solid ideas down first. And then this is complicated. If you have a negative on the x on the inside of the logarithm, then that's a y-axis reflection. Be careful. Please listen to what I say. Try to listen, because I'm not going to write it. What if on the inside it said log of, parentheses, 2 minus x? Which way would that shift? To right or to left? To right. You know why? Because you pull out a negative first, and when you pull that out, that can be rewritten as negative, then parentheses inside those parentheses, x minus 2. 2 minus x becomes negative 1 times the quantity x minus 2. Therefore, it's to right. Did you get all that? Too much verbalization? Well, you'll get an example of that. And then on the outside of the parentheses, plus d is an up-down shift. Okay, we're still going to input-output, but then we're going to analyze, did what I input-output make the translations really fit? I think that's a smarter way of doing it. Because sometimes when you do the translations and you do them out of order, then you have an incorrect graph. And input-output would not coincide with what you did. So it can be problematic. Input-output always what? Works. As long as you know how to evaluate. And it really hammers down what graphing is. It really does. Okay, I'll press pause for those that are still writing some stuff there. All right, let's move on. All right. Shh. What'd you say? Oh, okay. Oh, what's that? Maybe, I don't know. What if she does now? You'll feel terrible. I'm just kidding. Okay, anyway. You don't even know what we're talking about. All right. Okay. What does the plus 2 do? What's the plus 2 do? Up to. But hold on. What's ln? What's ln? Okay, now, I'm going to be perfectly honest. Okay, I didn't mess this up. No way. No way. I didn't mess this up. But first hour, I did something different. And this is okay. And then this will be proved. First hour, I plugged this in first. Do you want to know why? Everyone in this room should know what that evaluates to become. And then people are nervous now. This is based off of yesterday's stuff. What's ln, by the way? Log base what? What's log base e of 1? 0! And everyone should be able to get that quick. Nah, that's the naughty finger shown at you right there. Because why? What are we looking for? It starts with an E and ends with ponent. I don't have the time. We're looking for an exponent on E that equals 1 when we're done evaluating. So E to what power equals 1? Anything raised to the 0 power equals 1. But hold on, this becomes 0. What's 0 plus 2? 2. And there you go, input, output. And again, this is why I can't sleep at night. I think about some of you students that can't do this input-output even with lines or parabolas or cubics, and still not seeing this, and you're so reliant on the calculator, you're so on the low level in this class. Okay, you know what else you plug in? This is really what I should have started with. What is ln of 0? Meaning, okay, let's hold off. Remember I told you when we did that transformational worksheet, I said, you know what you should start with? Plugging in whatever makes 0 on the inside of the function, right? But in this case, what is that for the for this situation? Well, what's log? What e to what power equals 0? Is that even possible? No. So what is this? There's a whole bunch of undefineds, but this is the first one. So what is that? What happens at 0? And then this is where your memorization comes in. Oh, all right. Logarithms have vertical asymptotes. We just had that described by inverses, taking the inverse of the exponential function, and how the values approach that way. You know, blah blah blah. And of course, I can't plug in -1, -2, and -3. You can't take log of a negative number, ln of a negative number. You know what the next number I should plug in? This is weird. Why would I plug in e? What's ln of e? 1! Log base e of e. E to what power equals e? 1. What's 1 plus 2? By the way, what is e? A number. 2.718, comma 1, 2. Okay, you know what this? All right, now I kind of remember. I remember Mr. S blabbered about something, bragging about his college career first. And then then he said there was some asymptotic behavior, and it can look like that. It's good enough. We're done. Okay, except we're not. And then this is where I lament. This is where I want to cry. I really cry myself to sleep some nights. On the chapter 2 test, you know how many people on the chapter 2 test, those last questions, remember that crazy graph? And you had all those limit questions? How many people remember that? Okay, well, get ready to get yelled at when you miss these, because I don't understand what I can do for you, because I think we do this a lot, don't we? Like, what are the only questions we should be able to ask? As x goes to infinity, so as these x numbers are plugged in, where are the y's traveling to? Where are they going? What just happened there? Okay, they're going towards what? Infinity. And then the only question you can ask yourself on this one is the graph as x approaches 0. What's 0 plus mean? From the right. So as I plug here, 1 comma 2, but then as I plug in these numbers, as I get close, can you see my pen writing? As I get closer and closer to plugging these x's, this is where the y's are going. You got to understand that there's an infinite amount of coordinates, very small x's, comma, what kind of y's? Very big what? Starts with an N. Negatives. So that is negative infinity. That's what we're asking there. Then, of course, the domain is still 0 to infinity, and then the range will always be. Yeah, I will tell you this, too. You know, logarithm graphs, when you go to the graphing calculator, that kind of could look like, exponential with an asymptote there, couldn't it? And this is what students screw up all the time. When you plug a log on a graphing calculator and you plug an exponential on it, they look very much the same. They really do. So it doesn't help you plugging it on a calculator. You calculator copiers, the ones that must survive with those, cannot survive without them. You got to stop. Hey, what does that negative do on the inside of the logarithm? What does it do to the parent graph? Flips it over the y-axis. Then what is the -2? What should it do? Down. But you know what I did? Okay, I'm going to think about that, but then I'm also going to input say it. Can I even plug in one? That's not even a good point to plug in, by the way, and I'm glad I erased that. Can I even plug in one? No, because that gives me -1, and ln of -1 is undefined. That doesn't mean that's where the asymptote is. What should I find for the inside of the function? The 0. And the 0 for this is actually plugging in 0. That is the first undefined value. So the 0 of the inside of the function is where the vertical asymptote is located. And yes, that is what we did with transformations with our old stuff, except we never graphed a logarithm because we weren't ready. We didn't know how to evaluate a logarithm correctly. And then why did I plug in negative 1? What's a negative negative 1? What's ln of 1? What's 0 minus 2? So negative 1, negative 2, now it's time to analyze. Okay, so 0, 1 is the parent function. It got flipped over the y-axis and then moved down 2. Boom shakalaka. All right, that makes sense. You got it? Because sometimes when you do your transformations incorrectly, you do them in the wrong order, not following PEMDAS, then you get it in the wrong spot. And then not doing input-output would be a problem. Then why did I plug in negative e for x? What's ln of e again? 1. What's 1 minus 2? And then this just gives me my shape. Negative e is negative 2.718, comma negative 1. This is gold, guys, what I'm giving you. And you know what I did for first hour? And I know some of you hate when I do this. Does that mean I have to do this? I'm a robot. I'm only going to do everything that you do. Well, it really shouldn't be that way. How do you find an X-Intercept always? What do you do? And I'm just going to do it for giggles. This is for giggles right now. You plug in what for what? 0 for y. And don't tell me you cannot solve this. Because you know what? This was a question very similar to last night's homework. What do you do first to solve for that? Add 2. What do you do after that? Here, I'll write this to give you a clue. ln is log base e. What do I do next? That's your clue. Change it to exponential form. You drop the word log and then these are forced back into their positions. Base, exponent, answer. And then I could multiply both sides by a negative. And whatever 2.718 squared, negative, that's what the x-intercept is. Now, do you have to find that for sure? No, but I don't know. 3 squared is 9, so I'm assuming it's, I'm just taking a guess. All right, but at least you see the shape, all right? And then you can answer the questions. And then, of course, these are my questions that I like. I didn't do this in the last one, but the domain now is negative infinity to 0. And we should know that, and I shouldn't have to explain that. Look at the picture. It got flipped over the y-axis. There I go. I explained it. Blah, blah, blah. All right? And then as x goes to negative infinity, what is my y finger slowly but definitely rising to? It takes a long time, but it is going to infinity. And then the only thing you could ask now is 0 minus, as x approaches 0 minus. That's negative infinity. So sad how many people missed that. That was a siren. I thought that was going to be easy questions at the end of the test. All right, and then you know what f of questions? I instantly like f of negative 1 questions. What is f of negative 1? Let's just see if you're paying attention. It's negative 2. So I'm not making you draw the chart. I will probably ask you an f of question on the test, though, just to make sure that you know how to even evaluate a logarithm and then to understand input, say it. All right, so input x, output y, and then that's the coordinate. Okay, graphing 101. I don't think I have 2 anymore. Boo! What's the boo? Log base 10 of x minus 3. What can we expect with the minus 3 in this case? What can we expect? Right 3. What should I plug in my chart? You know, and you could do this mentally. What should I plug in first for x? What do we do in the transformational graph section when we did that weeks ago? I only heard one person say it. What should I plug in? You know why I'd plug in 3? What's 3 minus 3? What's log of 0 always going to be? It's not 1. Oh my gosh, they got it wrong again. 10 to what power equals 0? Nothing. And then what does that mean this is? Whenever you get your log of 0 value, what is that? That's where the asymptote is. So 1, 2, 3, x equals 3 is the asymptote. Oh, okay. What did it get moved? It got moved what? Right 3. That proves it. The asymptote gets moved right 3. What's the next number I should plug in the chart? This makes me sad if we don't get this one. 4? Why would I plug in 4? What's 4 minus 3? What's log of 1? 10 to what power equals 1? 0. And this is who's going to get crushed in this class. Those that cannot evaluate a logarithm mentally and think about it and get those things figured out from yesterday's homework. Whoa! Sorry about that, Boba Fett. All right? Got a little toy Boba Fett in the room. I accidentally hit him. What's the next number I should plug in? This would be abstract if you can figure this out. This is 4th hour. Who just said 13? I almost said his name, but then I put you on the internet, and then you can sue me. Why 13? Person in the back who shall not be named. 13 minus 3 is 10. What's log of 10? 1. Because 10 to the first equals 10 because the invisible base on that logarithm is 10. So now that stinks. All this shows is this is really, really, really close to the x-axis for a while. But you know what? It still rises forever. Okay, so, and then those are the questions I would ask. I'd ask, what's f of 4? And then 4 minus 3. And I'm just trying to get you to understand logarithms and understand that that's 0. And then I would ask you, what's f of 13? Just plug in 13 minus 3, get 10, and log base 10 of 10 is 1. I will ask you these questions just to make you think. Input, say it. And that turns into a coordinate that actually should exist on your graph, although 13 comma is too far away to graph on this. And then the domain has now changed to 3 to infinity. The range is always. And then, and I have no time for this. As x goes to infinity, you should figure out very, very, very slowly it still goes off to infinity. It's crazy. And then 3 plus, the graph is going down to negative infinity for y's. All right, and then because of time, I gotta show this one real fast. Spent too long talking about my glory days of college. Okay, when you see this, you should rewrite this as negative log parentheses negative parentheses x minus 1 parentheses. To keep that all inside the logarithm, you have to factor out a negative because there's what kind of reflection? Y-axis. And then which way does it move? Right or left one? Right, actually. And then plus 1. So y-axis reflection, this is right 1. This is up 1. But do those at the end. We're going to input, say it. Okay, and I know I'm going over this fast. I just want to get the video complete. This is the last example. You know what? Forget about it. I should know what to plug in right now. What should I plug in for x first? 2 is a good answer. I would accept that. But I was looking for something else. I was looking for the asymptote. What should I plug in for the asymptote? 1. Because it gives me log of 0. And I couldn't care less if there's a negative and there's a plus 1. What's undefined with a negative on it? Plus 1. Undefined. And it's the first point where this graph is undefined. So at x equals 1, oh, okay. Everything gets moved right 1, which I said in my reflections. So, of course, the asymptote from the parent function, which is the y-axis, should move right 1. Now, why did he say 2? What's 1 minus 2? 1. So what's negative log of 1 and then plus this 1 on the outside? I've got to be careful. What's log of 1? 10 to what power equals 1? 0. Is there any such thing as negative 0? No. So what happens when I plug in 2? What did I get? 1. Did I do that right? Oh, yeah. 2 comma 1. Hold on. I feel like I did something wrong. Hold on. Let's pause the video. What time is it? You're killing me, Smalls. What's everybody? What's 1 minus 2? Negative 1, which is undefined. Sorry, buddy. That was wrong. What should we actually plug in? 1 minus 0. We should be plugging in 0 for x. We plugged in an illegal value. 1 minus 2 is not. It's negative 1, which would have been undefined. Good, I like when I make little mistakes there. I knew something was wrong because of reflections. Y-axis reflection, the graph should be over here. Huh? Do you hear me, everybody? So I caught my own mistake by putting two things together here. And this shouldn't confuse. Okay, why would I plug in 0? Because then that would be negative log of 1 plus 1. Now I can ask the question, what is log of 1? 0 plus 1, which is 1. 0 comma 1. I don't really see the shape there. What's the next number I should plug in? Come on, you got it. What's the next number I should plug in? Anyone know what the next number I should plug in? This does make me sad that no one can figure this out except for one person. I'm looking for log 10. What do I plug in for x to get log 10? Negative 9. Okay, what's 1 minus negative 9? It's actually 10. But then you get a negative on there and then a plus 1. What is log of 10? 10 to what power equals 10? 1. What's a negative 1 plus 1? So actually at negative 1, okay, I got it. This graph is going to do this, come up, and then approach the asymptote from this side. That's why I want to find the other point. Okay, fine. What happened to this graph? It got reflected over the y-axis, reflected over the x-axis, then moved. So here's 1, 0. Reflected over the y, reflected over the x, doesn't do anything, then moved up 1 and right 1. Isn't that end up at 0 comma 1? Right? That's why input-output coincides with this. All right? Sorry for that little mistake we made, but again, by concrete knowledge, I knew I made a mistake somewhere because I knew the reflections were involved in this.